So welcome everyone. In this question we are going to discuss the solution of clone graph. In this we are given a node of connected undirected graph. We have to return a deep copy of the graph. So in this basically um, there is a graph in which each node is a class which contains two attributes, value its value and neighbors. The basically it is a list of the neighbors of the node, and the graph is undirected graph and it is connected. So basically the deep copy means that we have to return a clone of the graph. So basically all the connections should be same in the graph, except the fact that the node should not be same. So like example, this is the original graph, so we have to return a clone of that graph, but the nodes have to be different. So like 1 2 3 4, the connections are in this order. So in the new graph also connections should be in this order only, but the nodes should be different. So basically this node cannot be this node or any other node in this graph. So it seems a pretty simple problem, and it is. So basically um, consider this graph: 1 2 3 4 and 5. So consider this graph. So and this is a reference node, the node given to us. So we have to make a clone of this graph. So automatically it is intuitive that we have to do some sort of traversal on this graph. So which is the best traversal on this graph? We can either do BFS or DFS. So suppose we are doing DFS. So consider simple DFS, like we are on the node 1 and we are doing DFS. So we in doing DFS we reach 2, then we reach 4, then we reach 3, then we reach 5. So while simultaneously we are while we are doing the traversal, simultaneously we are also creating a clone. So suppose we are at node 1. So um, basically there's a stack, and on the top of the stack there's node 1, and basically we will make a clone of the node 1 if it is not already made. So initially there's no clone of node 1, so we make a clone of node 1. So like this is a circle, which means that a clone is already made. So clone is made, and now we would get all the neighbors of this one, so it would be 2 and 3. So now we will check 2. So the basically the clone of node 2 is not already made, so we would make clone of 2 also and 3 also. And in the we are given the neighbors of the nodes in this format: self, like a node dot value, node dot neighbors. So in this clone of 1, we will also add the neighbors as the clone 2 and clone 3. So now suppose in DFS we reach 2, so we would check its neighbor. So 1 will already visited, so it would not be checked. But 4's clone we will create, and then add the neighbors. We would add node 1 and 4. So after seeing the solution, it would be more clear. Solution is very easy. First will be the base case. If the node is not there, then we return none. Else we create two dictionaries, or in C++ type language we create two maps. Dictionary, basically this would map the original node to the new node. So like this would map 1 to this one, 3 2 to this 2, 3 to this 3, 4 to this 4, and 5 to this 5. And so we are doing DFS. So I'm doing iterative DFS. We would create a stack which would contain node, visited of node would be true, and I create a clone of this node, and head would be this, as I am returning this node. And while stack, we pop the front of this stack, and we traverse through its neighbor if the clone of its neighbor is already created, we don't come here, or else we create a clone. So as I was talking is, currently we are in node 1, then we will check node 2 and node 3. If clone of any one of them is not created, we clone it, we create its clone, and we append the clone of the child, in the clone of the node. So that's what we're doing here. The clone of the node, we are appending the clone of the child in its neighbor. And this is simple TFS if else. So if the child is not visited, so like we are in 1 and 2 is not visited, so visit 2, and after that we return head. So as you can see, it is accepted.